Welcome to The Explainer. Today, we're going to talk about a massive shift that's happening in technology right now. It's this powerful convergence of different fields that's creating what some researchers are calling a systems revolution. And trust me, it's set to change, well, pretty much everything about business and society.
So what does a systems revolution actually mean? I mean, it sounds big, right? Well, it is. We're not just talking about a slightly faster computer or a clever new piece of software. Nope. What researchers at theCUBE are pointing to is a complete, ground-up transformation in how we build and connect our technology. It's like rewiring everything, from the cloud down to the physical world, to create what they call a cognitive enterprise. To really get our heads around this, we're going to break it down and look at it in 3 distinct layers. And it all really boils down to this one central question. What happens when artificial intelligence gets a physical body to interact with the world, a connected brain to process everything, and a conscience to make sure it operates responsibly?
All right, let's start with the part you can actually see and touch, the body. And in the world of AI, that body usually comes in the form of a robot. This is where the digital brain finally meets the real physical world.
Now, in robotics, there are 2 totally different philosophies kind of battling it out for the future of automation. On one side, you have the efficiency-first camp. These are specialized machines built to do one single thing, but to do it perfectly, over and over again. On the other side, you have the flexibility-first approach, general-purpose humanoid robots designed to do, well, just about anything a person can.
So let's dig into what makes them so different. Specialized robots are all about the hardware. They rely on things like programmable logic controllers, PLCs, and they thrive in controlled, structured places like a factory floor. The return on investment? Super predictable and proven. Humanoids are the complete opposite. They're software first, driven by this idea of embodied AI, which is just a fancy way of saying an AI that can learn and act in our messy, unpredictable world. Their payoff is a huge question mark, but it could be astronomical.
Look, if you're a factory manager, the math for a specialized robot is a no-brainer. You can calculate exactly how much you're saving in costs and gaining in speed, and you'll probably get your money back in just 1 to 3 years. For any business that just needs to optimize a process they already have, this is the safe, low-risk way to go.
But humanoids? Whoa, that is a completely different story. This is a high-risk, high-reward gamble on a future of what some people are calling hyper-abundance. When Tesla aims for a price tag around $20,000, they're hoping to create a smartphone moment, making a general-purpose robot so cheap it becomes a platform that changes everything. This isn't about making one task faster, it's a bet on creating entirely new industries.
Okay, so we've got the body, but a body is pretty useless if it isn't connected to the brain, right? You need a nervous system, and that brings us to the second invisible layer of the cognitive enterprise, integration.
And this quote from Capgemini absolutely nails it. You could have the most incredible robot in the world, but if its AI brain can't actually connect to your company's data, your apps, and all your other systems, well, its intelligence is trapped. It's basically a very expensive paperweight. It has no real power to act.
And believe me, this isn't some small problem. A staggering 95%, almost every single IT leader, says that connecting AI to their existing systems is a huge challenge. Just try to imagine getting hundreds of different apps built over decades, each with its own silo of data, to talk to a brand new AI. It's a mess. And that gap is the single biggest thing holding back the cognitive enterprise.
So what's the solution? Well, it's a whole new approach to architecture where you intentionally build a dedicated integration layer. This is that nervous system we were talking about. It acts like a universal translator or a bridge, connecting the data at the bottom with the applications and the AI at the top. This is what finally lets information flow freely, and it's what enables the AI to actually take meaningful action.
But as we start connecting everything together, a new critical problem pops up. With all this data flowing between different clouds and thousands of devices, how in the world do we make sure we can trust it all? How do we keep it secure?
Seriously, think about it for a second. When data and commands are jumping between different companies, different cloud providers, different AI agents, how can you possibly be sure that information is authentic, that hasn't been messed with? Our traditional security models, which kind of rely on a central gatekeeper, they just weren't built for this decentralized world.
This is where something called distributed ledger technology, or DLT, comes in. You probably know its most famous form, blockchain. The easiest way to think of it is as a shared digital notebook that isn't owned by any one person. Every transaction gets recorded,
verified by the entire network, and then cryptographically sealed. It creates a perfect, unchangeable, tamper-proof record that everyone can trust. And the cool thing is, this isn't a one-size-fits-all technology. You've got different flavors. Platforms like Hyperledger are designed specifically for businesses, creating private, permission networks where transactions can be kept confidential. Then, on the other hand, you have platforms like Ethereum that are built to be public and permissionless, creating a giant transparent network for general use.
Okay, so let's recap. We have a body, we have a connected brain and a nervous system, and we even have a layer of trust. That brings us to the final, and I would argue the most critical piece of the whole puzzle, the conscience. This is the human layer of governance.
And here's the crucial point. Building all this stuff isn't just a technical problem, it's a human one. If we don't have clear rules, proper oversight, and a real strategy for using this power responsibly, we could end up with systems that are totally misaligned with what we actually want and need.
A good governance plan is really built on 4 core ideas. First, fairness, making sure the AI isn't just learning and repeating all the biases from our old data. Then you need transparency and explainability, so we can actually understand how an AI reached a decision instead of just treating it like a magic black box. And finally, you need accountability, which just means having clear lines of responsibility for when things go wrong.
And really, all of this leads to what's called the human-in-the-loop imperative. It means we have to design these systems so that human judgment is built in at the most critical decision points. That's how we make sure these powerful tools stay aligned with our goals and, even more importantly, with our ethics and our values.
So as we assemble all these pieces, the body, the brain, and the conscience of these powerful new cognitive enterprises, the final question we have to ask ourselves isn't just about what we can build, it's about what we should build. The ultimate challenge of this systems revolution isn't just about creating an intelligent enterprise, it's about building one that we can truly trust.